Hello, and welcome to the AI Research Roundup. I am Alex, and today is May 16th, 2025. Fresh off the press, published just yesterday, May 15th, from Hugging Face's trending list, we are looking at a research paper titled Beyond AHA, Towards Systematic Meta-Abilities Alignment in Large Reasoning Models. This paper explores how large reasoning models, which often use step-by-step chain of thought reasoning, can have these aha moments that are unfortunately quite unpredictable. So this research proposes a way to systematically teach these models three fundamental reasoning skills: deduction, which is like logical proof; induction, or finding patterns; and abduction, which involves forming the best explanatory guess, making their advanced reasoning more reliable. Okay, so this first figure really visualizes this core idea, presenting what the authors call a unified reasoning framework. It is built around those three meta-abilities we discussed: deduction, induction, and abduction. Meta-abilities in this context are fundamental, higher-level reasoning skills. The diagram shows a triangle with hypothesis, rule, and observation at its points. So if you have a hypothesis and a rule, deduction helps you infer an observation. Similarly, combining an observation and rule leads to a hypothesis via induction, and an observation and hypothesis can infer a rule through abduction. This given two, infer the third structure is key. Alright, building on that unified reasoning framework, this next figure lays out the author's proposed three-stage pipeline. Stage A is the meta-abilities alignment. Here, separate models are trained for deduction, induction, and abduction, using specific synthetic tasks. For deduction, they use propositional satisfiability, which essentially checks if a complex logical statement can actually be true. For induction and abduction, they use reverse rule graph search, which involves working backwards through a network of rules to find explanations or patterns. Then, in stage B, there's parameter space merging, where the learned internal settings of these specialized models are combined into one. Finally, stage C applies domain-specific continual reinforcement learning, or RL, a training technique where the model learns from rewards to fine-tune this merged model on tasks like math and coding. So this table then details the results of that final stage, the continual domain-specific reinforcement learning. It compares baseline instruction-tuned models, which are models fine-tuned to follow general instructions, with two versions that underwent this further reinforcement learning. One version started from that instruction-tuned model, while domain RL meta started from the meta-ability merged model. Across math, code, and science benchmarks, for both 7B and 32B model sizes, the domain RL meta approach consistently achieves higher scores. This really underscores that initializing with those aligned meta-abilities elevates the final performance ceiling attainable. Okay, so before that final domain-specific reinforcement learning stage, this table provides a closer look at the impact of meta-ability alignment and merging. It compares the baseline instruction-tuned model with models separately aligned for deduction, induction, and abduction, and crucially, the merged model. Across math, code, and science benchmarks for both 7B and 32B parameter scales, this merged model shows significant gains, with these benefits holding as models get larger, boosting overall average performance by about 2.5% for the 7B model and 3.5% for the 32B model over the baseline. The table also lists an Oracle ensemble, which is essentially a theoretical best-case scenario, showing the upper limit if all specialist abilities could be perfectly combined. So to bring our discussion on this work about systematic meta-abilities alignment to a close, it is clear that explicitly training large reasoning models for fundamental skills like deduction, induction, and abduction, then merging these, builds a much stronger foundation. This structured process means models not only start with better reasoning, but also reach higher performance ceilings after further domain-specific training. This moves beyond relying on unpredictable aha moments or just latent chain of thought abilities, which are the model's inherent, sometimes hidden, step-by-step problem-solving pathways towards more controllable and scalable AI reasoning. Thanks for tuning in to the AI Research Roundup. I am Alex, and I will see you next time.